When we know how to measure an angle in radians, in addition to obtaining a simple formula for calculating arc length, we can also obtain a simple formula for finding the area of a sector of a circle. A sector is in the shape of a piece of pizza or a piece of pie. It's like a triangle with an arc on the end. The area A of a sector with a central angle alpha in radians in a circle of radius r is given by A equals alpha r squared divided by 2. Now, we can derive this in the same way that we derive the formula for arc length. That is, if we find the ratio of the area of the sector to the area of the entire circle, which is given by pi r squared, then this is going to be the same as the ratio of the central angle alpha subtending the arc, defining that sector, divided by the central angle subtending the entire circle, which is 2 pi. We can solve for the area A by multiplying both sides by pi r squared. Notice the pi's would cancel over here on the right. And we obtain the formula A equals alpha r squared over 2. Now, it's important to remember where these formulas come from. In fact, if I can remember where it comes from, I'm more likely to remember the formula. So the area of a sector is given as alpha r squared over 2. Now, just as we saw with an arc length formula, we have made the assumption that alpha is measured in radians. So this particular formula only works if the angle is given in radians. We made that assumption right here using 2 pi for the angle for the entire circle. If we wanted to measure the angle in degrees, we would have to replace that 2 pi with 360 degrees. Ultimately, it would affect the way our formula works if the angle is given in degrees. So to adjust this formula to fit an angle given in degrees, we would have to take that angle in degrees and convert it to radians by multiplying by pi over 180 and then multiplying by the r squared over 2. This would yield the formula A equals alpha pi r squared divided by 360. So the formula is much simpler when the angle is given in radians. Let's try the following example. A center pivot irrigation system is used to water a circular field with radius 200 feet. So imagine a circular field where the radius of that circular field is 200 feet. So this may represent farmland, for example, and you're using the center pivot irrigation to water that farmland. As the irrigation system rotates, then it's going to water the farmland in the shape of a sector of a circle. In 3 hours, the system waters a sector with a central angle of 68 degrees. So in 3 hours, it rotates 68 degrees. What area in square feet is watered in that time? Well, notice the angle is given in degrees, so we're going to have to carefully convert that to radians before we calculate the area of the sector. You can either use this formula and do it all at once or take it in a 2-step approach. I'm going to go ahead and take the 68 degrees and I'm going to convert it to radians by multiplying by pi over 180. So we end up with 68 pi over 180. I want to go ahead and reduce that. I'm just going to use my calculator to do that. 68 over 180. I'm going to reduce it, math number 1 fraction, and I'm going to get 17 over 45. So in radians, 68 degrees is 78 pi over 45. No, I'm sorry, that was 17 pi over 45. So that's the angle that I'm going to use in the area formula. So the area formula is alpha r squared over 2. So now we can plug in 17 pi over 45. times the radius, which is 200 squared, all divided by 2. So I'm going to type that into my calculator all at once, and we're going to round to the nearest square foot. So we have 17 pi divided by 45 times the radius 200 squared, all divided by 2. So to the nearest foot, we have 23,736 square feet. So approximately 23,736 square feet watered in 3 hours. So once again, just like with the arc length formula, be sensitive to whether the angle is given in degrees or radians, and make sure you add that formula to your memory bank.